This question is a typical product mix problem which is quite suitable for linear programming formulation. An organization produces two products A and B. Each unit of product A requires 50 units and 30 units of raw material 1 and 2 respectively. Similarly, for product B also the requirements of these raw materials are given as 30 and 60 units. The daily availability of raw material 1 and 2 are also known, that is 1500 units and 1800 units respectively. The profit value is given. On product A the profit is rupees 350 per unit, and on product B the profit is rupees 450 per unit. In this question it asks what is the maximum profit the organization can earn per day. Since raw materials are limited, we cannot produce infinitely, and so the profit value, maximum profit value, will always be limited. Data from that question has been presented here in tabular form. Product A and product B, profit values are given here, 350 and 450 rupees per unit. Product A requires 50 and 30 units of raw material 1 and raw material 2. Similarly, product B requires 30 and 60 units of raw material 1 and 2. The availability of raw materials are given as 1500 units per day and 1800 rupees or 1800 units per day. So these data are presented in this table. We formulate the linear program here. So let quantity of product A being produced is X and quantity of product B being produced is Y. So X and Y become the decision variable. Our task is to find out the value of X and Y in such a way that maximizes the profit. Now if you write the expression for profit, since 1 unit of product A gives 350 rupees of profit and we are producing X units of product A, so the profit from product A will be 350X. Same way, profit from product B will be 450Y and the total profit will be 350X plus 450Y. Raw materials are required. So if we take raw material 1, since we are producing X units of product A and each unit of product A requires 50 units of raw material 1, so 50X is the consumption of raw material 1 in product A. 30Y will be the consumption of raw material 2 in product B, and the total consumption will be 50X plus 30Y, which should be less than equal to the availability, which is 1500. Similarly, for raw material 2, 30X plus 60Y less than equal to 1800, that becomes the constant. And the two non-negativity constant, that is X greater than equal to 0, Y greater than equal to 0, also we have to take. Now let us take the first constant, that is 50X plus 30Y less than equal to 1500. 50X plus 30Y less than equal to 1500. We are trying to find out the feasible space, such a space which satisfies this constraint and also X greater than equal to 0, Y greater than equal to 0. So you see in this graph we have X axis and Y axis. We are trying to draw the straight line 50X plus 30Y equal to 1500. This is a straight line which represents 50X plus 30Y equal to 1500. You can draw this straight line in whatever way you want. Here we have found out 2 points, like if X equal to 0, then 30Y will be equal to 1500, so Y equal to 50. So a point 0, 50 will be lying on this straight line. Same way, if you take y equal to 0, x becomes 30, and you have another point 30, 0 on the straight line. You can find out any 2 points on the straight line and then you can draw. So we have taken a point 30, 0 here and 0, 50 here, and this is a straight line which is represented by 50x plus 30y equal to 1500. Now since the constant is 50x plus 30y less than equal to 1500, we need to work in the area which gives 50x plus 30y less than equal to 1500. All the points lying on this straight line, they will be giving us 50x plus 30y equal to 1500. So one way is that you check the origin 0, 0. If you substitute the value of x as 0 and y as 0, you will be getting 0, which is less than 1500. So this side, that is the downside, where you find origin is lying, and that is giving you the value of 50x plus 30y less than 1500. So this particular region, which is highlighted here, this region will be giving you for every point such value of x and y which gives 50x plus 30y less than 1500. Also x greater than equal to 0 and y greater than equal to 0. So this space which you are seeing here, that satisfies these constraints 50x plus 30y less than equal to 1500 and x greater than equal to 0, y greater than equal to 0. We need to take care of another constraint which is being posed by raw material 2. Here you see that the second constant also has been incorporated. This line is 50x plus 30y equal to 1500. That is the constant related to raw material 1. And since raw material 1 consumption has to be less than equal to availability, we have to work below this. The other line, this is related to the second constant, that is raw material 2. 30x plus 60y, that is the consumption of raw material 2, and 1800 is the availability. This line is 30x plus 60y equal to 1800. Since we have to keep it less than equal to 1800, we will have to work in the area below this line. We also have to maintain that x is greater than equal to 0, that is this side, and y greater than equal to 0, that is this side. So if we have to satisfy all these 4 constraints, that is 50x plus 30y less than equal to 1500, 30x plus 60y less than equal to 1800, and x greater than equal to 0, y greater than equal to 0, then we will have to operate in this area. All the points lying in this area are satisfying all the 4 constraints, so they are feasible. Points which are not in this area, they will violate one or other constraint. For example, if you take any point here, this point will be satisfying the constraint of 30x plus 60y less than equal to 1800 because it is lower than this. That is, it will satisfy the raw material 2 constraint. But since it is above this line, the line which is represented by raw material 1, so if you want to produce something represented by this point, you will not have sufficient raw material 1 to produce it, though raw material 2 is available. If you take any point here in this area, you will find that raw material 1 as well as raw material 2 are not available in sufficient quantity to produce something represented by this point. So our feasible space is this. So now here we have the feasible space. The optimum solution will be one of these points. So now let us see the objective function. The objective function is here. We have to maximize 350x plus 450y, which is the profit. So maximize 350x plus 450y, and you know that the maximum value will be coming at one of the extreme points. It can be here, that is at the origin, or it can be at this point, or it can be at this point, which is another extreme point, or it can be here. We have these 4 extreme points. We can take it as, say, 1, 2, 3 and 4. The extreme point 1, that is x equal to 0, y equal to 30. Extreme point 2, that is 0, 0. Extreme point 3, that is 30 and 0. And extreme point 4. Since we have drawn the graph here, and you can do it by observation also, that this is a point of intersection of the two constant line, and if we drop a perpendicular from here, this point to the x-axis, we notice that x is somewhat higher than 17 and y is somewhat higher than 21. If you look very carefully at this point and see about the x coordinate, you can see that it is just higher than 17 and y is just higher than 21. So we can do the computation for say 17, 21. Let us evaluate for these points, that is 0, 30, 0, 0, 30, 0 and 17, 21, where this 350x plus 450y, which is the objective function, gives us the highest value. This option 0, 30 is equivalent to producing product B in 30 units and product A in 0 units. So the profit which you get, that is 350 into 0 plus 450 into 30, which will be equal to 13,500 rupees per day. For 0, 0, the profit will be 0. For 30, 0, if you are producing 30 units of product A per day, then you get the profit of 350 into 30 plus nothing of product B, so 450 into 0. This gives you 10,500 rupees per day as the profit. This option, where you are producing 17 units of product A per day and 21 units of product B per day, the profit comes out to be 350 into 17 plus 450 into 21, When you compute this, you get 15,400. In fact, we have done some approximation here, this 17 and 21. If you look at the graph, this point is somewhat higher than 17 and 21. You can get the accurate value by solving these two equations. That is, if you solve 50x plus 30y equal to 1500 and 30x plus 60y equal to 1800, then you will be getting a very accurate value. But approximately we can see that 15,400 is the profit which we can generate, somewhat higher than 15,400. The exact value comes out to be somewhere around 15,600. So if you look at the options, then 15,600 seems to be the right answer. So our choice will be 15,600. Though 1600 and or 16,000 and 16,600, these two options, they are higher than 15,600, but we don't have sufficient quantity of raw material 1 and 2 to produce so much of product A and B that generates this much of profit.